Hi everyone, and well done for finding the video. This is all about finding missing angles, and it is the Getting Secure version. I want to start off by thinking about angles around a turn and around a line. So if I was to do one whole turn like this around a point, I'd of course have done a 360 degree turn, like maybe a skateboarder would do. I know that that's one whole turn, 360 degrees. The angles around a line, much like a protractor from here to kind of a half a turn round to here, are 180 degrees. And of course I know that a right angle there is 90 degrees. Now if I know that a whole turn is 360 degrees and I know that this bit is 90 degrees, I'll also know that 3/4 of a turn is 270 degrees. So it's kind of split into quarters of 90, another 90, 180, that's a half, and another quarter for 3/4 is 270 degrees. So we were talking last week about different kinds of triangles, and this one here of course is an equilateral triangle, all sides the same length and all angles equal. Now we know that all the angles in a triangle add up to 180 degrees, and so if I've got an equilateral triangle with three angles the same, then of course the 180 degrees I'll have to divide by those three angles to work out that they are angles of 60 degrees each. And on the protractor that would be a 60 degree, another 60 degree to 120, and then the third one. So those three angles add up to 180 degrees, just like all angles in a triangle do. Now here, this one of course is our isosceles triangle because it's got two sides of the same length and two angles that are the same. Now in an isosceles triangle, if I know, for example, one angle here, that will allow me to work out the size of the other two angles, which of course are the same as each other. And then finally, of course, we've got our right angle triangle. Now, the thing, of course, we know about that is that one of its angles is 90 degrees. And then we'll know that these two angles will also have to add up to 90 degrees, so that the triangle has angles that add up in total to 180. See if you can use that information to work out the three missing angles, the three blue angles here. So pause the video and have a go. So starting with the triangle on the left hand side, of course I know that it's got one angle of 30 degrees, and I know that these two angles are the same, and that overall it must add up to 180. So if I do 180 and take off that 30 degree angle, I will of course have 150 degrees left that those two angles must add up to. And so then if I divide that 150 degrees by those two angles, I know that each angle must be 75 degrees, which of course looks about right when you think that that would be about a right angle. For the second example here, again I know that the three angles have got to add up to 180 degrees. If I add 125 and 32, I will get 157 degrees. And then if I take 157 off 180, I'd probably count on, think 3 more to get to 160, and then 20 more to get to 180, 23 degrees. And then finally, of course, this angle's 90, this angle's 55. If I add them together, that's 145. So the remaining angle here must be 35 degrees, so that all three angles add up to 180. Now, I'm going to show you how you can use all the information we have on this page to work out this missing angle just here. So I know that this angle is 28 degrees, and I know that the angles in a triangle in total are 180 degrees, and I also know that in an isosceles triangle, two of the angles are the same, which of course are these two here. So if I do 180 degrees minus that 28 degrees, I know that I'll have 152 degrees, which must be the amount that these two triangles add up, these two angles, sorry, add up to. Now, if I split that 152 degrees by 2, I'll have what each of those angles is, which of course is 76 degrees. I was thinking there, 150 divided by 2 is 75, 2 divided by 2 is 1, so if I had the 75 and the 1, I've got 76. So I know that that angle is 76 degrees. Now, of course, the final stage is if I know that this bit is 76 degrees, I know that this whole turn is 180, and if I take off the 76 degree bit, I'll have 180, take away 76, And that, of course, will leave me with an angle of 104 degrees. And I could check that that angle's about right, because, of course, that must be about a right angle. And so it's a little bit more than that 90-degree angle. So that means that my answer there is kind of realistic. So see if you can work out the size of angle X, just marked here. Pause the video and have a go. Okay, again, of course I know that all three angles must add up to 180 degrees, and I know that one of them is 110 degrees. So if I do 180 degrees and I take away that angle of 110, I'll be left with 70 degrees. And I know that the two angles on the bottom must add up to 70 degrees. I also know that those two angles have got to be the same because it's an isosceles triangle. So if I divide that 70 degrees by 2, I'll have what each angle must be. 35 degrees. And finally, this is one of my favourite questions. It's quite a tricky one. Have a go at this and see if you can work out the size of angle X, just marked here. Pause the video and have a go. Well, the first things to figure out is, first of all, it's a rectangle, and so we know that all the angles in the rectangle are 90 degrees, so we know that that angle's 90 degrees. And then, like we said at the start of the video, it's an equilateral triangle, and that tells us that all the angles are equal. This one, this one, this one, they're the same, and they add up to 180 degrees. So, of course, each one must be 60, and that one, crucially, is 60 degrees. Now, if I note that this turn here is 90 degrees, it's made up of 3 bits, a 12-degree bit, a 60-degree bit, and the rest. Okay, so those two sections in total are 72 degrees, and the whole thing is 90 degrees, so that bit must be 18 for all 3 angles to add up to 90 degrees. Well done, everyone. Thanks for watching the video. I hope it was useful, and we'll see you in the classroom next week.